Arm signals with outstretched arms to each side and do a slow repetitive gesture from top to bottom. Emergency positioning indicating radio beacons, that's the EPIRBs. This is used to signal an emergency location. Signal transmitted by radio telephony or by other signal systems. SOS in Morse code or possibly using a flashlight. A shotgun or other explosive signals may be fired at intervals of about 1 minute. A continuous sound with any fog signaling device. Rockets or shells that shoot up red stars one at a time at short intervals. Use distress flags N and C from the International Code of Signals. A rocket parachute flare or hand flare shoots up a red light. A smoke signal that gives off orange-colored smoke. A piece of orange canvas with a black square and a black circle. A dye marker.
Parts of an APIRB, strobe light and IR LED. HRU or hydrostatic release unit. Bracket, pull tab, switch, indicators, wrist strap, lanyard. Parts of a SART, hanger eye, antenna, test button, red LED, activation button, metal strap, GPS zone. Parts of a marine radio, HI/LO key, satellite icon display, volume control, squelch control, selector key, lat/long display, menu setup, access menu, distress button, 16/S key, clear key. Search patterns. Search patterns are methods for systematically traveling over the surface of the area of water in which the target is likely to be found, while observers and/or instruments are deployed with the intention of detecting the targets of the search. An effective search pattern is one in which the entire surface can be examined with a good chance of detecting the target if it is present, but without excessive overlap, though some overlap is usually considered advisable to allow for inaccurate estimates of target visibility and sea and atmospheric conditions. Expanding square. Expanding square search patterns utilizing more than one vessel should follow the same steps as one vessel operations, but include the following considerations. The second vessel is to commence the same pattern, but orientated 45 degrees. If the same speed is used for both vessels, the first vessel must be allowed to complete at least 3 search legs before the second commences to avoid risk of collision. Sector search. A sector search, also known as a Victor Sierra (VS), by the U.S. and Canadian Coast Guards, is a search pattern suitable for a small object in a well-defined location that covers a circular area centered on a reported position using a route made up of straight line segments that efficiently covers a circular area and is adapted to account for drift. First, the search vessel makes a measurement of the drift speed and direction using a datum drift marker to indicate the drift in real time. The pattern is steered relative to the datum marker, and the track over the ground may look considerably different due to superposition of drift. Parallel track, also known as Papa Sierra (PS). This pattern is useful for covering a large area where no accurate datum is available. It can be used by a single vessel or several vessels, and for any size of target, though the distance of advance between search legs will vary depending on the estimated visibility of the target. D2. Creeping line, also known as Charlie Sierra (CS). A creeping line search pattern uses as back-and-forth pattern of search legs spaced according to the estimated target visibility range, but with relatively shorter legs, and is used in similar circumstances to a parallel track pattern, particularly when the target is expected to be at one end of the search area. The creeping line is considered more effective in areas of drift or current constrained by shorelines, such as in narrow bays or channels, where the legs are run across the current and progress against the flow. Barrier search, also known as Bravo Sierra (BS). The barrier search pattern is used when there are strong currents or drift which are expected to carry the target through a gap between geographically fixed points of reference downstream of the estimated datum. The vessel will be steered to keep approximately on the barrier line as it repeatedly traverses the gap. Expanding square search. This pattern is used when the datum is relatively precisely known, and drift is likely to be small. The datum marker is deployed at the estimated datum, and the search starts from there, with the leg length incrementing by the same time at every second turn. All turns are 90 degrees in the same rotational direction, usually to the right. A constant speed of between 5 and 10 knots is suggested for a search for a person in the water, and leg length is determined by time. Track spacing is determined by visibility of the target and is equal to the length of the first leg. The track expands outward continuously and is superimposed over drift. It is necessary to keep accurate record of leg length increments to ensure that they occur at the right times and at the right turns.
Casualty won't be there. So, how do you do a Sharnov turn? Well, you start off by putting your rudder hard over. It really doesn't matter which way here, because the casualty fell over a while ago, so you've not got to move your stern away from them. Keep turning like that, and when your heading's changed by 240 degrees, which is 180 plus 60, turn your rudder the other way. You're going to continue to swing a bit, but the turn will build then coming on the other way. Then, once you're 30, actually, you just put your rudder hard over towards the casualty. Remember, it's only good if you've literally just seen them fall, so you want to be moving your stern away from them. Putting your rudder towards them is going to lift your stern the other way and hopefully keep them a little bit safer. Your vessel's going to continue to turn all the way round, and once you're 20 to 30 degrees short of 270 off your original track, then start to get your rudder back to midships. You should steady up on 270, just coming back in perpendicular to your original track. How do you do a Williamson turn? Say, for example, somebody falls in, they've fallen off the starboard side of the ship, and you actually saw them fall. First thing you want to do is put your rudder hard over in the direction they fell, so in this case, hard to starboard. It doesn't actually matter which way, because normally by the time the message reaches the bridge, they're well astern of you anyway, but given the choice between port and starboard, why not turn towards them and make an attempt to swing your stern out of the way? Once you're 60 degrees off your original course, you're going to put your rudder hard over the other way. Remember, you're not instantly going to start turning because it's going to take time for the rudder to get back to midships and back over the other side, and you're carrying the momentum in that turn anyway, so you're going to be swinging further than 60 degrees off, but it's all built into the turn. Just remember, once you're 60 degrees off, hard over the other way, and start that turn back. Once you're then 30 degrees short of your reciprocal, you're going to start reducing that helm. When you're 20 degrees off your reciprocal, get the helm back to midships. This gives you 20 degrees to carry a bit of momentum to hopefully naturally steady up on the reciprocal of your track. Although, as you're approaching the reciprocal, if you notice you've still got a big rate of turn, just use a bit of counter helm, try and get that down so that you steady up on the reciprocal of your original track. Notice that you're going to steady up before you get back to the casualty, so
the Charnow turn is a maneuver used to bring a ship,